What's up, guys? How's it going? Philip Start here, and welcome back to the 31st episode of my Spring Boot GraphQL series. Now, thank you so much if you've actually reached this far from the start, and I really hope you've enjoyed the series so far. But today's episode is going to be on Spring Boot security and securing your GraphQL endpoint. But before I talk about that and explain the methodology of what I'm going to do, please have a look here and enjoy the beautiful scenery. We just walked up here, or hiked up here, over the last 3.5 hours, and it's in Canton Bern in Switzerland. Beautiful, beautiful part of the world, one of the most beautiful parts in the world. And here you can see the iconic 4K peaks, just above Interlaken, which is below here. So this is Interlaken, and you can see, of course, the mountain range. Beautiful place to be. But anyway, so today, with our Spring Boot security episode, what we're going to do is we're going to use the methodology of pre-auth. And what I mean by pre-auth is the GraphQL server will accept in headers, and them headers are trusted headers, and they're going to contain a user ID, permissions, and roles. And they're trusted because we're going to run the GraphQL server on a Kubernetes pod, and the GraphQL server runs as one container, and there's another container runs in the pod, and that's called an Envoy sidecar. And what Envoy is going to do is handle all Ingres to the GraphQL server, and Envoy will perform the JWKS validation to actually authenticate the user and verify that their token is correct and it's from our server or auth server, and it's not expired and whatnot. And if it's a valid token, so it meets the cryptography and it's not expired, then we're going to extract the information out into headers, permissions, roles, and user ID, and send that into the GraphQL server. So we know that by the time we reach the GraphQL server, the user or these values can be trusted and we can operate on them. And why this is also cool and used pretty heavily nowadays is if you integrate with other systems and they don't use JWKS, you can have another authentication method within the proxy that can handle another token or another method of security, extract out the headers into the same header names, and that will be forwarded into the GraphQL server. So now you can operate and serve requests from many different auth servers or many different supported security servers. So I hope that made sense, and I'm going to show you guys. So first of all, I'm going to dive into the GraphQL piece, and I'll show you guys how to do it with pre-auth. We can use some annotations on our resolvers, and then how you can propagate the actual security and permissions or the JWT token onto servers or onto external services beyond that. So guys, hope you enjoyed this, and I'll see you in the code, but have a look at this once more, and take it easy, guys. Enjoy your day wherever you are, and I hope you guys enjoy this episode. So before I start coding, I would like to show you a nice diagram on the istio website. So if you don't already know, istio is a service mesh that will run on Kubernetes. And in this diagram they have on their website, it's a really nice example of the pre-auth scenario I just explained. So you can imagine here, this API content is your client, so that can be someone who's using a UI, so user interface with a JWT, or it could be, let's say, an external web service also. And what happens is when they send their request in, of course it goes through the Ingres routing, and that will route the particular request based on like the URL to the correct pod that can serve that request. So after that, before it can actually talk to the GraphQL service, which is running here in service A, it has to talk via this proxy. And this proxy can be istio, this can be Envoy, it could be Kong, it could be anything. But this proxy will actually ensure that the JWT is valid, and it does that by verifying its signature against the JWKS. And if it's a correct signature, it also ensures that the likes of the token has not expired. And if it is valid, it means that we can trust the token's content because it has not been tampered with. So this is great because we can now extract that logic, instead of having it in our service, which is our actual GraphQL service, we have that in the proxy. So we have that in another, what we call like a sidecar running on Kubernetes, or in istio's way, we have that in the service mesh. So this is amazing for us, and this is the basis of this tutorial. So you can imagine that you have already verified that the JWT is valid and correct, and it's went through this process from the proxy, and it sends in the JWT to the service, plus it'll also send in the headers containing the JWT data, because that would be common throughout most services too. So we can enrich that to send in the user ID and the user roles that have been extracted from the JWT. Now, if you like this and you want to read more, you can come here to istio, you can read a good bit more, and the likes of istio. If you do this, the proxy can actually support multiple JWKS certificates. So if you support multiple auth providers, then you can have them both in the proxy, the certificates, and therefore it doesn't matter which user connects with a bearer JWT token. As long as it's signed by one and only one of them supported, then it can come through to the GraphQL service. So if you come into tasks, you can go into security, you can go into authorization, and then you can see the JWT. And this is what like some common code would look like. This is where the JWKS would live. And you don't have to do this just with istio. I mean, I was reading some OpenShift blogs, and of course you can come in here and they run like their own container using a gatekeeper that will actually guard the application. So I mean, you don't have to use istio as a service mesh. You can do this with a simple container running as a sidecar. So you just need to make sure that all Ingres routes through the sidecar before it talks to the service, and that's very important. So I'm going to get started here and write the pre-auth code, so you can see that in a further tutorial if you like. I can actually show you some of the Kubernetes stuff as well. But if you haven't already read, please come here and read the Spring Security Architecture wiki, because I won't be going in detail on what every little thing does. Come here, have a good read. This explains most of the detail in a high enough level that you can still see the classes and really understand what they're doing. So that being said, let's jump over to the code, and I want to get started here. So let me just get my IDE set up, get this here. So what I've done is I've actually coded this already, and the reason I did that is because it's quite a lot of boilerplate code, and I'd rather just talk through it rather than mash it out on the keyboard. I mean, you can see that on any other videos on YouTube, but here let's just come and have a chat. Let's chat about this. So the first thing we do is we want to secure our GraphQL server. So we dump in this GraphQL security config, and of course we follow standard Spring Boot, standard Spring Security procedure, and we extend this web security configurer adapter. And inside here, first thing we need to do is actually set the Authentication Provider. And in order to do that, then we override this method configure, and inside here what we do is we create a pre-authenticated Authentication Provider. Now these are actually Spring managed classes, so these exist in the Spring framework packages. And what we do here is we create this provider and we inject in this authorities user detail service. So what this will do is whenever we authenticate and we get the token here, it's going to actually come down and it's going to extract out the user details and verify the user details, and if they're correct, then it basically builds the pre-auth final token that will be used throughout the whole code base when we perform the Spring Security context holder checks or pre-auth validations and whatnot. But I'll come back to this in a minute and you'll understand a bit more what this actually means in 1 second. So that's provided, and then what we need to do is actually set up this Spring Security endpoint. So the first thing we want to do is add a pre-authentication filter, and if you're not sure what filters are, you can come to this tutorial and you want to read this section, because we have normal servlet filters that'll execute like this, But then we also have a special one, which is Spring Security Servlet Filter, which contains a filter. It's called a filter chain proxy, and that contains another list of filters for Spring Security. So this comes in, executes these, and then continues. So very important that you understand that process of Spring Security. So in here, what we do is we add a filter, and this is going to be the pre-auth filter. And inside this pre-authentication filter, so we extend of course the Spring one. So the pre-auth filter, we need to extend this. And what we want to do is set the principal and set their credentials. Okay, so we set the pre-auth principal to the user ID, because if you remember from the istio example, what we're going to do is we're actually going to extract out, in this example, the user ID and the user roles and send them in as headers enriched to the GraphQL service, just to help us out a bit. So here we can expect the user ID, and we can trust it because it's coming from our sidecar, and we set that as the principal. And of course we don't use credentials, we're passwordless, we're using tokens, so we can set this to empty. So that's cool, that's fine and dandy. Then what we need to do is actually set the details source, and what this details source is another class that I created, and this will extract out the user roles. So that's the second header, and it'll basically build up authorities, which will be simple granted authorities, build a list of these, and return this as a request, as the pre-auth web authentication details object. Now, a simple authority just represents a role. So as you can see here, it's a role. So we'll have a list of these, so basically a list of roles, and these are set as authorities passed back in the pre-auth granted authorities class. So we have that. So it's going to come in, it's going to run the filter. Filter's going to extract the user name, or which will be inside the principal. It then enriches it with the detail source, sets authentication manager, and if we fail, then it cancels it. So we do not want to continue fail. If we fail fast, we like to fail fast, and that's perfect. So if you want to actually read that a bit more, you can come down here and you can read. So let's say principal change, this is all basic stuff. Do authenticate. So get authenticated principal, it's when we overrid, get the credentials, and then we get the details. So it has the token, has the principal's credentials, sets the details, and then calls authentication manager dot authenticate. And then that authenticate actually is going to call our provider, which is this guy. So you can imagine here. So it passes the token into here, which is the provider, and then it performs some basic checks, which says, okay, the principal there, of course it is, credentials not there, no, because it's optional. And if it's there, if it's got that far, then we actually need to load the user details. And in this example, we're going to set this class, of course, as I just explained, the user details class, to this pre-authenticated granted class. And in this, all we do is simply take out the granted authorities that we already have and return that as user details. So in user details, we have the principal name, which is also known token name, and the authorities. So it's the roles. So now we have a pre-auth user all nice and ready to use. We authenticate all requests to all endpoints and disable the basics, and we want to allow actuator, because if we have health checks on our system, then we need to permit that. We don't need a token for a health check if you're calling it from internal on the cluster. So let's go ahead and actually debug this and run this in, and I can show you. Actually, before I do that, I had to do a few more things. So quickly, what I did was I enriched the exception handling, and we now handle access denied exception. So if you didn't have a permission, this would be thrown, and we would return internal server error. Now we return a forbidden, so 403 response code, which is more user friendly, saying, okay, you can access the data, but you can't access all the data because you didn't have a permission. So we've done that. And then what we then need to do is actually add a pre-authorize to our endpoint. So now we can go ahead and use these annotations. So let's go ahead and debug this. I'm going to breakpoint this at a few locations to explain this once more. So let's go ahead and come in here. I come down, breakpoint here. We'll go here and then authenticate, which we'll call the provider. This dude. And okay, let's go. So let's go ahead and debug this. So let's see if our request so here we're in the abstract pre-auth processing filter. So this is the filter that executes at the very start. So you remember here. So this we're inside here. And in here we go get the principal, which is Philip. Credentials, none. So that'll be defaulted. And then here once we've got the credentials, we then create a token and then we add the details source, which is going to add the pre-auth, so the authorities. So now we have the authorities set into the pre-token, and then we call authenticate, which is going to call the provider. So now we're inside the provider. The provider is then going to come down, and we're going to actually get the load user details, which basically just does what we've done. And in this, it creates the username with Philip and the authorities populated. So it's just the default operation. And user details checker, this is where you can provide like an overridden implementation where you could perform like extra checks about the user account. Is it active? Is it not? Stuff like that. In this case, we just use Spring's default one, which is, yeah, in our case, no op basically. And we'll just actually check the booleans to be precise, but it's no op in terms of functionality. And then we would create a final token, which this final token as a result is going to be used when we use our annotations, and these authorities are going to be to actually validate it. So then we play that across, and as you can see now I'm inside the controller, which is annotated with get bank account, so we must have this authority, and I sent this in with the request in user roles, therefore it succeeds. So we come here, we get the data. Now if I say bank accounts like this, and I stop this and I rerun this, it will fail. And what we'll also do is we'll add another pre-authorized to the balance service. So we'll do that on the resolver actually. So this guy here. So get bank account balance, and let's run it this time. So we come back and we play. You'll see it's forbidden because we don't have get bank account, we just have get bank accounts. So we have bank account and we get this, and it still shows this because we've asked for balance and we don't have the balance actual permission. So let's go ahead and delete balance, and now there's no errors, but we get balance back and we get the error again. And here what we can do is add another permission. So we say get bank account and we add balance. Now the error goes away and we would have got the balance. Let me change the ID to be one with a balance. So balance service, we'll take this guy, put this in here and play that. Now we get balance 1. If I change this to balances, then balance is null and we get forbidden. And GraphQL actually encourages you to delegate this to the actual service class that holds the data and has access to it. So I recommend you have your policies at the actual data level, like where the data lives, rather than at a GraphQL server. But as an MVP, many people have their whole app in one server, which is this GraphQL Spring Boot server. So this is how you would do it in that case. So we delete this. And we just have one more problem here. So if I put a breakpoint in here, because you remember that this executes in another thread for the data loader, so it's in a completable future. Well, we don't actually have access to the Spring security there because it's in another thread. So if we come back here and we play this, play this through. So I have the Spring security. So if I come in here and I type in Spring security context or holder, was it Spring context holder? Security context holder, sorry. Security context holder. Get context. So we'll see the context because this is executing in the normal Tomcat-based thread. So we'll see the context, and in here, this is where permissions are going to be validated against. So in here, you can see that we have these two permissions, and that's fine. Copy that. And then we have a breakpoint in our balance service, which, as you see, executes in one of the thread pools. Now if we call get context, it returns null. So that sucks because we might need the security context in there to perform some validation, or we might need to pass these credentials to external services or pass that JWT to the external services. So how the hell do we propagate that into there, and how do we get that on any async stuff? Well, Spring Security is very generous. The guys at Spring are pretty amazing. So they've basically developed what I have done here. So I have a correlation ID propagation executor, which will propagate the correlation ID, and that's in another video. Well, what they have done is created something similar, only it doesn't just wrap the correlation ID and pass that in. It actually passes the security credentials plus the execution that you want to execute. So it sets the credentials on the executing thread, the target thread. And that's called this delegating security context executor service. So what we need to do is basically wrap our already wrapped executor with that delegating security context executor service. So we come in here and go boom boom, and we extract that. And there's one actual more use case here. So what I would do in this case is I would extract out all these three into a single method to ensure that every single thread pool we create has all of the proper delegation classes to propagate the stuff through the threads. And we know that when we execute in Java, unlike Kotlin where there's coroutines, when we execute in Java, we know that there's only one thread executing that thread at any one time. So we know that it's impossible that two threads are going to be accessed. Two threads are going to currently access the same piece of code and on the thread. So we can never have two different context holders in that same thread because it has to, the threads take turn in executing that. So that's a really, really good guarantee by Java to ensure the correctness and the correct state of our security context holders. So go ahead and debug this, and let me go ahead and pop that request in. So now we have the context folder. So again, type this security context folder, context. There it is. Let's play it in. And we didn't get to the balance service. Why not? Oh, I didn't have a breakpoint. So play again. So we have the server, we know it's there, and then here we now, which what we didn't have before, we didn't have the context, it was null, and there it is. So there's the token passed straight through, and of course you can see it's the same token. So E2E. So really, really cool and good work by them guys for providing that class, and that's how you would propagate through. So let me play this once more, and let me add some more stuff. So it's going to be invalid, forbidden, or if you have extra ones, so we say get world, and of course it's still the same, it's still forbidden. So we play this. So now we finished the request. Sorry, there's someone process there. We've get account balance and get world, so keep playing that, no problem. So you can continue adding some. If you change one, then you have the forbidden. So that's super nice from Spring. Please read this guide. So if you didn't understand what I just explained, this guide really explains everything. And here at the bottom, it basically explains how you can propagate to async methods, or you can do whatever you want to do. So anything else I should say before I wrap this up? Yeah, basically the other comment I have on GraphQL and security is there's no right way of doing this. So there's no correct way. I mean, and that's because there's many correct ways, and it really depends on your ecosystem, your environment, what you guys choose as an individual, maybe as your own startup, your own business, or at a medium or larger corporation or company or a small company. I mean, you want to choose something can be like a standard and consistent across your services. You don't want different auth techniques or all these different mechanisms, because it's going to be really hard to maintain in the long run, and can just open up doors for attacks when you can minimize them and stick to the basics, do it right, and pick one for you that can actually work. So I'm going to commit this code. It's on GitHub. You can go and have a look and enjoy. And I hope you enjoy the rest of your day, and I will see you in episode 32. Take it easy, guys.